Hello, today you are watching this video on 3.1. Hopefully, move up a level on your 3.1 standards base grade. I can solve systems of linear equations by graphing. By now, you've learned multiple ways to solve systems of linear equations, but today we're just going to focus on pretty much what is a system, how do I find the solution to a system, and how do I find that solution by graphing specifically. So, what is a system of linear equations? It is a set of two or more linear equations, is called a system of linear equations. Primarily, we focused on just two equations at a time and found the system from them. I believe you had a problem or two in your practices that dealt with more than two. And then the solution. We found multiple ways to find solutions, but a solution of a system of linear equations in two variables is an ordered pair xy that satisfies each equation in the system. And remember, it has to solve both equations or be true in both equations in order to be a solution to the entire system. So let's take an example here of solutions. So it's asking me right now, I have two equations, and it's asking me if 4, -6 is a solution to this system of equations. So I'm going to take my xy coordinate, and I'm going to plug those values into my equation to see if it is true. So I take y is -6 equals -5, x is worth 4 plus 14. So here I have -5 times 4 is -20 plus 14 is -6. And my y value is -6. So yep, it checks out. That is a solution to that equation. It also has to be a solution over on this other side. So again, y is equal to -6. X is equal to 4 minus that 10. So 4 minus 10 is -6. And it checks out here. It is a solution to that one. Since it's a solution to both of the equations in the system, then yes, it is a solution to the system. Your turn. Go ahead and plug in the coordinate 0, 3 into both equations and let me know, is this a solution to the system of equations or not? All right, so let's check and see if you are correct. So for y here we have 3 equals -5 times 0 minus 3. So 5 times 0 is 0, minus 3 is -3, equals 3. Oh, no, it's not a solution. Okay. Over here, let's try this side. I have 3 equals 3/8 times 0 plus 3. 3/8 times 0 is 0 plus 3 is 3, and this one is a solution. However, 0, 3 is not a solution to the system of equations because it does not work for both equations in the system. So this would be a no, this is not a solution. Okay. So let's get into, well, how do I find those solutions if they don't just give them to me to plug in? So we're going to look at this first example. Um, the nice thing about this is this first example is already in slope-intercept form. So I'm just going to use my quick and easy slope and y-intercept to graph this line. So I'm going to go up to 1, 2, 3, 4, 5, 6 plus 6. And then I'm going to go up 1 over 3, 1, 2, 3. Up 1 over 1, 2, 3. And I can go down 1 over 3 also, as long as I have a positive slope. And I'm going to graph that line. It is extremely important that you are using a straight edge when you're graphing these systems of equations to make sure that you're graphing nice straight lines so you can see where they do intersect. And we could continue that as long as we needed to. Now, the second equation is not in slope-intercept form, so the first thing that I would have to do is to solve it for y in order to put it in slope-intercept form so I can graph it that quick way. So when I add 4 to both sides, I end up with y equals x plus 4. Now I'm ready to graph, so I go up to 1, 2, 3, plus 4. And my slope says I have to rise 1, run 1. And I can go down 2 if I want to. And you can already kind of see where the solution, where those two lines intersect. Now I'm going to kind of graph it out here just to make sure. We'll assume that's a straight line that goes through those points. Okay, good thing I put a lot of points on my line because my line's a little off. That's okay. And you can see right here that this point is where they intersect, and we can see that is at coordinate 3, 7. So I think my equation, the solution is 3, 7. But I'm going to plug these both in just to make sure. So if I plug a 3 in for x, 3 plus 4 is 7. So yep, that one checks out. Over here, if I plug a 3 in for x, 1/3 times 3 is 1, plus 6 is 7. So yep, that one checks out. It's true for both equations, which mean it is true for the solution. And I have found my solution. Okay. It's your turn now. Your responsibility here before you meet with your teacher is to graph these 6 systems. The first 3 are already in slope-intercept form for you, so you just have to quickly graph them, find their point of intersection, and then don't forget that you need to check your solution. Okay, so I should see the work of you, not only the graphs, but I should see that you are plugging the numbers or the coordinates that you get back into your equation to verify that it is a true solution to that system. You have additional step in 4 through 6 because you can see that those are in standard form. So you're going to have to find an alternate way to graph those, either by rewriting them in slope-intercept form or by finding the intercepts and graphing them using intercepts. I should see that work along with the graph and then also checking your solution for 4 through 6. When you get done with these 6 problems, it is time for you to set up an appointment and interview with your teacher to see if you are able to move up on your 3.1 standards based grade.